Natural gas dehydration is a process gas producers use to remove water vapor from their gas flow stream. To do this, producers introduce a liquid called triethylene glycol into their gas. In this video, we'll explain how to determine how much glycol to circulate in a system to properly dehydrate your natural gas. Generally, a glycol circulation rate of 3 to 5 gallons per pound of water to be removed is sufficient to adequately dehydrate the gas. However, if the glycol flow rate is too high, it can overwhelm the reboiler and you will lose efficiency. There are two factors that help to separate the water from the glycol: residence time and heat. If you don't allow the glycol enough time to reside in the reboiler, it will not increase the temperature of the glycol enough to remove the water and achieve optimal purity levels, which are 99% or more. If the glycol flow rate is too low, you will not be removing enough water vapor from the gas traveling through the contact tower to achieve your desired dew point level. Here's how to calculate your glycol circulation rate to determine your glycol pump speed. Step 1. Use your water vapor content of gas chart to identify your water content. Let's use an example of 80-degree gas at 600 psi. That tells us that the water content is 50 pounds per million cubic feet of gas. Step 2. Multiply your water content by the gas flow rate. In this example, our flow rate is 4 million, so we'll need to multiply 50 by 4. This gives us 200 pounds of total water to be removed per day. Step 3. Multiply total water content, which is 200, by the gallons of glycol needed to remove 1 pound of water, which is 3 to 5 depending on the glycol purity and temperature. So in our example, we'll use 4. This gives us 800 gallons of glycol per day. Step 4. Divide the total amount of circulated glycol per day by 24 to calculate the per hour rate. 800 divided by 24 gives us 33.3 gallons per hour circulation. Step 5. Using the glycol circulation rate chart, identify your Kimray pump size to find the circulation rate closest to your calculated rate to determine the ideal pump speed. In this example, we're using a 90/20 PV pump, which puts us between 14 and 16 strokes per minute. As a general rule, round up to the nearest stroke count, which is 16 strokes per minute. This is the pump speed we need to maintain to circulate a rate of 800 gallons per day. Now that you have this number, you can change your pump speed to match your conditions and dry your gas sufficiently. To do this, adjust your needle valves equally, counting the strokes per minute to verify the correct change has been made. Your glycol flow rate should be checked on a regular basis to prevent both over-circulation and under-circulation. To speak with somebody about your dehydration system, contact your local Kimray store or authorized distributor.